So now we look at stage 2. So stage 2 means that you have to look at item number 2. And for item number 2, the weight for every item is 3 kilogram, and the return or the revenue from item 2 is 47. For the state, since we have 4 maximum capacity, so it remains from 0 until 4. Okay, x2 equals to 0, 1, 2, 3, and 4. Now, for the m, okay, m2. So, m is we want to decide on the number of units of item 2. So, before that, we have to take the maximum capacity, which is 4, and then divided by the individual weight. So, 4 divided by 3, you got 1 point something. Okay, 1.33 something. But we cannot take 1.33 unit. Okay, we should take the integer only. So in this case, we take 1 unit of item 2. I mean, the maximum unit of item 2 is 1. So your M2 will be 0 and 1. Now, for the function that we are going to use for stage 2, it will be f2 x2. Okay, and remember, because we want to maximize our return, so it will be maximize 47 m2. Okay, why 47? Because the return for item 2 is 47. And you have to add with the feasible solution from previous stage. So in this case, because we have calculate for stage 3, so it will be f3 and then x2 minus the weight for item 2 is 3 m2. And remember, we should also alert about the infeasible area where we should exclude from our calculation. So your xi should be greater than equals to the weight and also the unit of item. So in this case, if let's say for m2 equals to 0, okay, never mind. Okay, because we can start from x2 equals to 0. But when m2 equals to 1, okay, so 1 times the weight, okay, the weight here is 3. So 1 times 3 is 3. So your x should be greater than equals to 3. So in this case, there is no value when x equals to 0, when x equals to 1, and when x equals to 2. So your calculation or your value will start when x2 equals to 3 and then continue with x2 equals to 4. Okay, so now we just substitute m2 equals to 0 into this function. Okay, so 47 times 0 is 0 plus this is the function, okay, f3 x2 minus 3 m2. So you just substitute x2 equals to 0 and m2 equals to 0. So 0 minus 3 times 0 is 0. So it basically x3 here, because remember this is actually x3. So x3 will be 0. So when x3 equals 0, we recall back our stage 3. So this is our stage 3. When x3 equals to 0, the value of f3 x3 also equals to 0. So we will use this v0 in our iteration in stage 2. So the value here will be 0. So 0 plus 0 equals to 0. Now, when x2 equals to 1, just substitute into the equation. So 47 times 0 is 0 plus x2 equals to 1. So 1 minus 3 times 0 is 0. So basically, we want to find f3 1. Okay, where 1 here is actually our x3. So again, go back to stage 3 and get the value of when x3 equals to 1. So when x3 equals to 1, the value is 14. Okay, so you add 14 here. So 0 plus 14 is 14. And you have to do this for all of the value. So now when m2 equals to 1, okay, for m2 equals to 1, again substitute the m2 equals to 1 and the value of x2 into this equation. Okay, so 47 times m2. So now m2 equals to 1. So 47 times 1 is 47. And you have to plus with when x2 equals to 3. So it will be f3. x2 is 3. So 3 minus 3 times 1 is 3. So it will be f3 0. And another one is f3 and x2 is 4. 4 minus 3 is 1. So we need to get this value from our previous stage. When x3 equals to 0 and x3 equals to 1. Okay, so when x3 equals to 0, the value is 0. And when x3 equals to 1, the value is 14. So we have 0 and 14. So 47 plus 0 is, this one is 47. And this one, 47 plus 14 is 61. Now we can find the solution here. Okay, again compare 0 and then 14. Okay, when x2 equals to 2, this is 28. When x2 equals to 3, you have to compare between 42 and 47. And since we want to find the maximum value, so our answer is 47. And the last one, you have to compare between 56 and 61. And maximum value is 61. Now, what is the optimal of M2? Okay, so from here, 0 comes from when M2 equals to 0. The 14 here comes from when M2 also equals to 0. 28 also comes from when M2 equals to 0. Okay, 47 comes from when M2 equals to 1. And finally, 61 comes from when M2 equals to 1. Okay, so now we move on to stage 1. Okay, so for stage 1, represented by item 1. Okay, and each item, the weight is 2 and the return or the revenue is 31. Okay, for the state, yes, again, since we have 4 capacity, so you will list from 0 until 4. Okay, and then for the alternative or the decision, so you have to test the number of the maximum number of unit for item 1. So in this case, since we have 4 capacity, so 4 divided by 2, because 2 is the weight for item number 1, so 4 divided by 2 is 2. So that means your M1 is from 0, 1 and 2. For the function use, okay, so for now we are at step 1, so F1 x1 is equals to the maximum of 31. Okay, so 31 of M1, and then you have to plus with the optimal solution from the other stage. So it will be, because this is stage 1, so now it is from F2 or from stage 2 x2, but x2 here is actually x1 minus the weight, which is 2 of m1. Okay, then we look at the invisible area. So how to check? Use xi should be greater than the weight and also the number of unit. Okay, so if let's say m1 equals to 0, okay, this one no problem. But then when m1 equals to 1 and the weight is 2, so it will be 2 times 1. So your x should be greater than 2. So here, when x should be greater than 2, so there is no value for when x equals to 0, when x equals to 1. So we will start our iteration when x1 equals to 2. Same goes here when m1 equals to 2. So the weight is 2 times the m1 equals to 2. So 2 times 2 is 4. So you have to make sure that your x should be greater than or equals to 4. So basically there is no value for x equals to 0, x equals to 1, x equals to 2, and x equals to 3. So we only will start the value when x1 equals to 4. Okay, so now just substitute the x1, the value of x1 and the value of m1 into this equation. So 31 times 0 is 0 plus, okay, it will be, so x1 equal to 0, m1 also 0. So this will be f2 of 0. Now check back your stage 2. Okay, when x2 equals to 0, the value is 0. So basically, it will be 0 plus 0, so you got 0. Okay, so do this for the whole values, for all the values. Okay, so that is for when m1 equals to 0. So we do the same for m1 equals to 1 and m1 equals to 2. Okay, so now for the optimal solution, this one for f1, x1. So again, compare, but when x1 equal to 0, there's nothing that you can compare, so the value here is 0. And then, again, when x1 equals to 1, nothing to compare, so this is 40. But when x1 equals to 2, you compare between 28 and 31. And remember, we want to maximize our return, so it will be 31. And then next one, when x1 equals to 3, you have to compare between 47 and 45. Okay, so the highest value is 47, and the last one, you have to compare between 61 and 62 and 59. So the highest value is 62. Okay, for the optimal m, okay, m1, okay, so this one come from 0, 14 also come from m1 equals to 0, and then 31 come from when m1 equals to 1, 47 comes from when m1 equals to 0, and 62 come from when m1 equals to 2.